Hello friends and my dear students, I welcome you all to my channel. I hope you're all well and your studies are also going on well. So this is part 2 video on the topic of area of a trapezium, where I will discuss how to find the area of a trapezium when all the length of all its sides are given. And this will be to find the area of the trapezium based on all the length of all its sides. We will use the Hero's formula for finding the area of a triangle. And finally, we will solve few examples based on the topic of finding the area of a trapezium from all its sides. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author R.S. Aggarwal. If you are new to my channel or not yet subscribed, if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with a part 2 video on the topic of area of a trapezium. Okay, so in this video we will discuss how to find the area of a trapezium when all the lengths of all its sides are given. So only the length of all its sides are given, but we are not given the height of the trapezium. We know that for finding the area of a trapezium, we need fundamentally we need three information: the length of the parallel sides, or even the sum of the length of the parallel sides, and the altitude or the height of the trapezium. But how do we find the area of a trapezium when height is not given, but all its length of all its sides are given? So this will be based on we will have to apply the concept of Hero's formula to find the area of a triangle. So first, you have already studied about the Hero's formula in your previous class. I will briefly recall what is Hero's formula. So Hero's formula is used to find the area of a triangle. So in this diagram, a triangle ABC, if the length of the sides are A, B and C, so the length of BC is A, the length of AC is B, and the length of AAB is C, then the perimeter of the triangle ABC will be A plus B plus C, and the semi perimeter, which is denoted by the small letter with the small letter S, will be equal to the half of the perimeter, that is half of A plus B plus C. Now the area of the triangle ABC as per Hero's formula is equal to root over S multiplied by S minus A multiplied by S minus B multiplied by S minus C. So this is the Hero's formula, where small s is the semi perimeter of the triangle, and the semi perimeter of the triangle, that is the half of the perimeter, and of course the perimeter is A plus B plus C. So let's say the area of the triangle be A, capital A. Now the concept of applying this Hero's formula to find the area of a trapezium is that we will apply this Hero's formula to find the altitude of the trapezium. Now altitude of the trapezium, but before that, using the Hero's formula, how do we find the altitude of the triangle ABC? Now in any triangle we will have three altitude depending on which base you are considering. There are three sides, so any side of a triangle can be considered as the base, and then the opposite and the perpendicular from the opposite vertex to that base is the altitude. For example, so if in the figure 1, triangle ABC is in the triangle ABC, if we consider BC as the base, then the altitude of the triangle will be the perpendicular drawn from the opposite vertex, that is A, on the side BC, which is AE. And usually we denote the height of any rectilinear figure, that is triangle or any trapeziums, rectangle, any plane figures with the small letter h. Also we denote the height of a trapezium with the small letter h. So in this figure 1, if we consider BC as the base, then AE, which is perpendicular to BC, will be the height of the triangle, and we know that the area of a triangle is half into base into height. So it will be half into AE into BC. So that is equal to half into AE multiplied by A. The length of BC is A, and where AE in this case is the altitude of the triangle, considering the fact that we are choosing BC as the base. So we will have half into AE into A is equal to A, where capital A is the area of the triangle. From here we will get the altitude AE will be equal to twice A by small a. So considering BC as the base, we have found the altitude AE to be twice of capital A divided by small a, where small a is the base length of the base BC. Similarly, if you consider any other base, for example, in figure 2, we are considering AB, the side AB as the, we are considering the side AC as the base. So the altitude will be the perpendicular drawn from the opposite vertex B on the side AC, which is BE. So BE, let's say, is H, that is the height. So in this, so for this triangle AC, if we consider AC as the base, BE will be the height. So the area of the triangle will be half into altitude into base. So half into BE into small b, where small b is the length of the base AC, which is equal to A, which will imply we will have BE is equal to twice of capital A by small b. So as you can see, when we consider AC as the base, the altitude of the triangle is twice of twice of the area divided by the length of the base. Similarly, in the figure 3, if you consider AB as side AB as the base, then the height of the triangle ABC will be twice of A divided by small c, where small c is the length of the base AB. So this concept will also be used, that is to find the height of a triangle from its area depending on what base we are considering. This concept will also be used to find the height of a trapezium. So these are the prerequisite concepts that will be required to find the height of a trapezium from the length of all its sides. Now let's see how do we find the area of a trapezium from length of all sides. So in this we are having a trapezium. It's a very general looking trapezium, PQRS, where PQ is parallel to SR and PQ is parallel to SR, and obviously PQ is not equal to PQ is parallel to SR and PQ is not equal to SR, and the non-parallel sides are PS and QN. So just for the for calculating the area, we have considered the length of the side PS, a length of the side PQ as X, length of the side SR as Y, where obviously as you can see from the figure, Y is greater than X. It could also be the other way around, X could be greater than Y, it does not matter. Also the length of PS is small m and the length of QR is N, that is the length of the non-parallel sides are M and N, and the length of the parallel sides are X and Y. Okay, so what are the steps to find the area of this trapezium? Now the primary objective is that we know the length of the parallel sides, that is which are X and Y. We need the altitude. We have to find the altitude. To find the altitude only we would need the Hero's formula. Okay, so what are the steps? So the step 1 is, first we will draw a perpendicular distance between the parallel sides, that is PQ and SR. So draw a perpendicular distance between the parallel sides, which will be the height of the trapezium. So now you can draw the perpendicular distance between the parallel sides from any vertex. I can draw from P on SR, I can draw from Q on SR, also I can draw from S on PQ or from R to PQ. It will not make any difference. Just for the sake of discussion, I am drawing the perpendicular from the vertex Q on the side SR. Now for finding the area of a trapezium, it is I will recommend that you draw the perpendicular from an end point of the smaller parallel side on the larger parallel side. In this diagram, SR is the larger parallel side, that is y is greater than x. PQ is the smaller parallel side and SR is the larger parallel side. So I have drawn the perpendicular or the height of the trapezium QT from Q on SR. So QT is perpendicular to SR. So this will be the height. This is the height of the trapezium. So QT is drawn perpendicular to SR. Let QT is equal to height, h height. The primary objective is to find h. Okay. Now the next step is we have to construct a triangle having same height as trapezium, which is QT or h, and whose base, that is the base of the triangle, will lie on the larger parallel side, that is in this diagram SR. We have to construct a triangle such that whose height will be the same as QT or h, and whose base will lie on the side SR. If we do that, then we will see that that triangle will have lengths of all its sides based on x, m, and x, y, m and n. If we construct such a triangle, the length of all its sides will be based on x, y, m and n, which are the length of the sides of the trapezium. How do we do that? So the concept is, from the vertex Q, I will draw a line parallel to the side PS. So I am drawing a line. This line is I am drawing. It may not look parallel, but please note that this is this line. Let's say this is QU is drawn parallel to PS. So we have PS is parallel to QU. Now, so we have QU parallel to PS. Now this will imply, note that, so we have a quadrilateral PQUS. In this quadrilateral, PQ is already parallel to SU. Since PQ is parallel to SR, PQ will be parallel to SU, and QU is parallel to PS. So PQUS is a parallelogram. So obviously the opposite sides will be equal. So we will have QU equal to PS. And what is PS? PS is M. PS is M. Okay. So this is how we construct now. So we have constructed the triangle we are trying to construct is QUR. So the triangle constructed is triangle QUR, whose height as you can see is equal to QT, which is denoted as small h, whose height is QT, and base is equal to UR. UR is the base. UR is the base. Now what is UR? UR is equal to, as you can see, it is nothing but SR minus SU. SR minus SU. Now what is SR? SR is the larger parallel side of the trapezium. So it is Y. And what is SU? SU is equal to PQ. Since PQUS is a parallelogram, SU will be equal to PQ, which is X. So we have the base as Y minus X. Base is equal to the triangle we have constructed. The base is the length of the base, which is UR, will be equal to the difference of the parallel sides of the trapezium, that is Y minus X. And the height is the same, QT, which is the height of the trapezium. Now also note that uh, what are the length of the sides of the triangle we have constructed. There is no space left. Okay, so the triangle constructed is QUR, and we will have, so we have in triangle QUR, what are the length of its sides? QU is equal to M. The base UR is equal to Y minus X, and the other side sorry, and the other side QR is equal to N. So you see the triangle we have constructed QUR, all its lengths are based on the length of the sides of the trapezium. So QU is M, UR is Y minus X, and QR is N. So now when we have so we know all the length of the sides of the triangle we have constructed, that is triangle QUR. Now applying the Hero's formula, the concept that I've just discussed, that how do we find the height of any triangle when we know the length of its sides. We will now try to find the height of this triangle QUR, that is QT, from all its sides. So now the next step is find the height of the triangle constructed in step 2 using Hero's formula. Okay, so we already know the length of all the sides of the triangle QUR. Okay, so area area of triangle QUR, based on Hero's formula, will be A is equal to area of QUR based on Hero's formula. Area A will be equal to, we know, S, it will be small s multiplied by S minus what are the sides, minus QU multiplied by S minus UR. I am not, so this is not a formula, I am just trying to explain the concept. When we will solve a problem, it will be clear. So S minus, and the other side is QR. We know already QU, UR and QR from the previous step. So this is the area of the triangle that we have constructed, that is QUR, where what is S? Where S is equal to half of the perimeter of the triangle, which is QU plus UR plus QR. So we know QU, UR, QR, so we will know S, small s, that is the semi-perimeter, and hence we will know the area A. So this will imply what is the height of the triangle QUR. It is QT. So QT, and the base is UR. So we can say that the height of the triangle will be, as per the formula that we were explaining, that it will be twice the area divided by the length of the base. So it will be the height of this triangle QUR, which is also the height of the trapezium, will be twice of capital A by the base of the triangle. It is twice of capital A divided by the base is UR. The base is UR, and obviously UR is Y minus X. So this is equal to UA twice of a divided by y minus x. So this is how we can get the height of the trapezium. Now once we have found the height of the trapezium, we can easily now find the area of the step 4. Next step is the area of the trapezium PQRS will be half into the sum of the parallel sides multiplied by h. H we have just found in step 3, and we already know the x and y, that is the length of the parallel sides. So this is how we find the area of a trapezium when all its sides are given, based using the concept of applying the Hero's formula. Okay. Now it might be sometimes tricky to how to construct the triangle QUR. So let me show how you will construct the triangle, this triangle, to find the height h of the trapezium, or the height of the triangle that we need to construct. How we will construct this triangle? So I have drawn few trapeziums. I will show for these trapeziums how do we construct the triangle. The main concept is that you have to construct a triangle in such a way that its height will be the same as the height of the trapezium. Now what is the height of the trapezium? It is just the perpendicular distance between the parallel sides. But remember that the base of the triangle that you are constructing must lie, preferably must lie on the larger side of the parallel side. So for the figure 1, the larger side is obviously SR. So I will construct the triangle in such a way such that its base lies on the side SR, inside the side SR, or maybe on the extended part of the side SR. Now, so okay. Now what will I do for figure 1? Okay. So from Q, you can see from Q. Now from Q, how do I if I draw a line parallel to PS for this trapezium, if I can draw a line parallel to PS from Q. This is the line. Sorry for it is not a straight line, but anyway, please consider that PS is parallel to, let's say this is QU. So I have constructed the triangle QUR by drawing a line from Q, by drawing a line QU which is parallel to PS from Q. So then we can the triangle constructed is QUR, where you will see that UR will always be equal to SR minus PQ. SR minus PQ. Let's say this is X and this is X. Let's say this is X, and let's say this is Y. The length of SR is Y and length of PQ is X. So this is equal to Y minus X. And of course, what will be so the triangle constructed is QUR, and the altitude will be the altitude of the trapezium as well as the triangle QUR will be the perpendicular drawn from Q to Q on the side SR. Now, if I extend the side SR and I draw the perpendicular, so this is perpendicular, let's say this is QT. QT is perpendicular on SR, so QT will be the height of the trapezium as well as the height of the triangle QUR. So we will have in triangle QUR, UR will be Y minus X, and obviously let's say if this is M, this is M, and this is N, so we will have QU will be equal to M, and QR will be equal to N, and height, the height is obviously QT, which is H. So the main concept is I'm trying to explain how do we construct the triangle. Okay. For figure 2, so as we can see, the larger side is on the upper is above, and the smaller parallel side, the larger parallel side is above, and the lower and the smaller parallel side is below. So it's no problem. So let's say this is x, that is I'm denoting the smaller the smaller parallel side as a with x. I mean the length of the smaller parallel side is x, and the length of the larger parallel side be y. So this be y. Okay. And let's say a PSBM, the length of PSBM and the length of QRBN. So for this quadrilateral, how do we construct the triangle? So always the concept is draw the perpendicular the triangle that we need to construct. Its base must lie on the larger parallel side. That is, in this trapezium, it will be on side PQ. Okay. So we can from the vertex S, I can draw a line parallel to QR. I can draw a line parallel to QR. So this is, let's say this be T. So ST is parallel to QR. So ST in the above example, QU was parallel to PS. And for the second diagram, we have drawn ST such that ST is parallel to QR. So this will imply that ST will be equal to QR, which is equal to N. Also, we will have TQ. We will have TQ equal to SR equal to X. Okay. Now the triangle formed is SPT. SPT is the triangle that we have constructed, and obviously, as you can see, the height of the trapezium will also be the height of the triangle SPT. So if I extend SR, so and draw a perpendicular PU on SR, perpendicular PU on SR, this will be the height. This will be the height. PU is the height of the triangle PUS as well as the trapezium PQRS. So we will have, for the triangle SPT, height is obviously is equal to PU. So we have height. What is the base? Base of the triangle SPT? It is PT, which is equal to PQ minus TQ. What is PQ? PQ is Y, and what is TQ? TQ is X. So we have, see, so it is, the base is always will be Y minus X. That is the difference of the larger parallel side and the smaller parallel side. And also we will see in the triangle SPT, the sides, the other two sides, ST is equal to QR, ST is equal to QR is equal to N, and obviously the other side is PS is equal to M. So you see that all the sides, the length of all the sides of the triangle SPT are based on X, Y, M and N. Okay. Now let's see for the third trapezium. So this is the smaller parallel side. Let's say this is X. So this is the larger parallel sides. PQ is the larger parallel sides. Let's say this is Y, and let's say this is M, and let's say this is N. So we have to construct the triangle so that the base of the triangle is on the larger side. Okay. So we will, as you might have already guessed, that I will draw a line from S parallel to QR. So this line segment is parallel to QR. Let's say this be is T. So and obviously I am not drawing the height. Okay, let me draw the height. If I extend the smaller parallel side and draw perpendicular from Q on SR, so this, so QU is the height of the trapezium, as well as, so what is the triangle constructed for this trapezium figure 3? The triangle constructed is triangle PST is the triangle constructed where height is obviously height is equal to the height of the triangle PST is equal to the height of the trapezium, which is QU. What is the base of the triangle PST? A base is PT, which is equal to PQ minus TQ. PQ minus TQ. What is PQ? PQ is Y. And what is TQ? TQ is equal to SR, since TQ SR will be a parallelogram. So TQ will be equal to SR. So this and SR is X. So Y minus X. And of course, the other sides are PS is equal to M, and ST is equal to ST will be equal to QR, which is equal to N. Okay. For the fourth figure, as you can see, this is I hope you have already got the idea how we are constructing the triangle. So for the fourth figure, so the smaller side parallel side is PQ and the larger parallel side is SR. So I will draw a line parallel from Q parallel to PS. So PS is parallel to, let's say this is T, QT. So the triangle formed is QTR. Where the base is equal to TR, which is equal to TR is equal to SR minus ST. Now, since QT is parallel to PS, PQTS is a parallelogram, so QT will be equals to PS. And also PQ will be equals to ST. So what is SR? SR is, we know, it will be phi. SR is the larger parallel side, so it is Y minus, and what is ST? ST is equal to PQ, and PQ is the smaller parallel side, which is X. So base is always Y minus X. That is the difference of the larger and smaller parallel side of the trapezium. And of course, we have PS is equal to, let's say, if this was M, this was N, and this was X, and this was Y. So we have PS equals to M and not PS, but the sides, the other two sides of the triangle formed is QTR. So we have QT will be equal to PS, which is M, and the other side is QR, which is equal to small m. So the base is Y minus X, and the other two sides, the base is TR, which is y minus x, and the other two sides are qt is equal to m and qr is equal to n. Okay. For the fourth trapezium, as you can see, DC ABCD is the trapezium. AB is parallel to DC. DC is the larger parallel side and AB is the smaller parallel side. So how do we construct the triangle? We will draw a line parallel from A to parallel to BC. So we will draw a line. They say this be E. So AE will be parallel to BC. So the triangle formed, and of course the height of this trapezium will be the same as the height of the triangle ADE. So the triangle formed is triangle ADE, where the base is DE, which is equal to DC minus EC. Now this is DC is Y, this is the larger parallel side, and EC is equal to AB, and AB is the smaller parallel side, so X. And the other two sides are AE. If you consider this is as X, this as Y, this as M, that is the length of the side AB is X, length of the side DC is Y, length of the side BC is small m, and length of the side AD is N, then AE will be equal to M and AD will be equal to small m. So I just wanted to explain how you will construct the triangle so that its base lies on the larger parallel side, and of course its height will be the same as the height of the trapezium. Once we have constructed the triangle, then you will follow from step 3. So you will know all the length of the sides of the triangle constructed. From the length of the sides of the triangle, you can find you will find the area capital A using the Hero's formula, and then from that area you can easily find the height of the triangle using the formula twice A divided by y minus x. The base of the triangle you will construct will always be y minus x. So the height will be twice of capital A divided by y minus x, where capital A is the area of the triangle you have constructed. So once this height h is also will be the height of the trapezium, and then we can easily find the area of the trapezium, that is half into the sum of the parallel sides, that is x plus y multiplied by height, altitude. So this was all about how do we find the area of a trapezium from the length of all its sides. First, the concept is, first we find the altitude of the trapezium by constructing the triangle using Hero's formula, and once the altitude is found, we can easily then calculate the area of the trapezium. I hope the concept is clear. If you have any kind of question or any query or any confusion, please be free to let me know in the comment section. I will highly appreciate that. Now let's try to solve based on this concept. Let's try to solve two problems that I have prepared. There are only two problems. Let's try to solve these two problems. The first problem says that ABCD is a trapezium with AB parallel to CD, and AB is to CD is to AD is to BC is 1:7 is to 3:7. That is the ratio of all the sides of the trapezium is given. Let's quickly roughly draw the trapezium. Roughly this is the trapezium. So as you can see from the ratio, parts of the ratio, AB parallel to CD, so AB and CD are the parallel sides, and the ratio of AB to CD is 1:7. So CD is the larger side, larger parallel side. So AB CD is the trapezium where AB is parallel to CD. Okay. Now we have given the ratio of all the sides. So if the height of the trapezium is 20 meter, the height of the trapezium is given 20 meter, find the area of the triangle ABCD. Now we don't know the actual length of the sides, but we know its ratio. Now if we assume the length of the sides based on the ratio, based on the given ratio, that is using a multiple of x, then clearly we can find the altitude height of the trapezium, that will be based on x. And since the altitude is already given, we can easily find the height of the trapezium. We can easily find x. Okay, let me do it. So we have let AB, I'm assuming the length of all the sides based on the given ratio. So let AB is equal to x. Why x? Because in the ratio the corresponding part of AB is 1. So let's say AB is x meter. Since the unit in the problem is meter, so I'm considering AB is equals to x meter, and let's say CD will be equal to 7x meter, and AD will be 3x meter, BC will be equal to 5x meter. These are all based on the given ratio. Okay. So we have AB is x. I'm not writing the unit. AB is x. DC is 7x. AD is 3x, and BC is 5x. So as usual, we will construct the triangle first. We will draw a parallel line. We will draw a line from B parallel to AD. So if we draw a line parallel to this is the line BE, which is parallel to AD. So draw BE parallel to AD. So this will imply that AB, this will imply that ABED is a parallelogram. Since already AB is parallel to DE, and BE is parallel to AD as per our drawing the line BE. So this will imply that BE is equal to AD is equal to 3x meter. Also BC, okay. Now and of course if I draw perpendicular on DC from the point B, the perpendicular, let's say if BF is perpendicular, BF is drawn perpendicular to DC, this implies that BF is the height of the triangle BEC as well as the trapezium ABCD. So what is the triangle we have constructed? The triangle constructed is BEC. So we see that in triangle BEC, what do we have? We have BE is equal to, I'm ignoring the unit, BE is equal to 3x. We have a BC is equal to 5x. We have EC, the base will always be equal to the difference of the parallel side of the trapezium, that is DC minus AB, which is 7x minus x, which is equal to 6x. Okay. So what will be the semi-perimeter of the triangle BEC? Smallest is the semi-perimeter of the triangle BEC. It is half multiplied by the perimeter of the triangle BEC, which is BE plus BC plus EC, which is equal to half multiplied by 3x plus 5x uh, plus 6x, which is equal to 8, 14, 7x. Semi perimeter is 7x. Okay. Now, what will be the area of the triangle AEC based on Hero's formula? Area A, let's say, of triangle BEC will be equal to, we know the formula is root over, it will be small s, that is the semi perimeter of the triangle BEC multiplied by s minus let's say BE, s minus EC, s minus BC. Okay, so this is equal to square root of, what is s? S is 7x. What is s minus BE? So s is 7x minus BE is 3x. S minus EC, 7x minus EC is 6x. And s minus BC, so 7x minus BC is 5x. Okay, so this is equal to 7x multiplied by 4x multiplied by x multiplied by 2x. This is equal to root over 56 x to the power 4. 56 x to the power 4. Now, if we bring the so this is equal to, we can say 56 multiplied by x to the power 4 means x square, square of x square. So I hope your concept of exponents are clear and square roots. So this will be equal to x square multiplied by 56. So the area of the triangle BEC in terms of x is x square into 56. Now, we know that the height of the triangle will be, so this implies the height h, or let's say what is the height BF. We know that BF, which is the height of the triangle as well as the trapezium, will be equal to, as per our discussion, it will be twice of the area of the triangle divided by the base of the triangle we have constructed, which is basically equal to the difference of the parallel sides of the trapezium. So which is it will be the base of the triangle. So let's say EC, and EC is nothing but okay. So what is A? A we have found to be 2x square, x square multiplied by root of 56. And what is EC? EC is if EC was the difference of the parallel sides of the trapezium, which was 6x, which was 6x, which was 6x. Okay, so this is equal to x square multiplied by root of 56 by, so this is equal to x, 1x will cancel out, this x will cancel x square with x, and this will be x by 3 multiplied by 56. Let me quickly check if I am doing correct or not, because I might be doing some calculation mistake. What is EC? EC is DC minus EC is 6x. Uh, okay. So if I am doing any kind of calculation mistake, please do let me know in the comment section. So we have this. Okay. So BF, that is which is the height of the triangle as well as the trapezium. We have found the height to be x by 3 multiplied by root over 56. Okay. Now, if this is so, we have found height, and we also know the parallel sides of the trapezium based on x. And we also know, okay, so the height of the trapezium is given. If the height of the trapezium is 20 meter, so height is given. So we can say that x by 3 multiplied by 56 is equal to 20. Now is equal to 20. So this implies that x will be equal to 20 multiplied by 3 divided by 56 divided by square root of 56. This is 60 by square root of 56. If I multiply, if I want to get rid of the square root in the denominator, I can multiply the numerator and the denominator by root 56 by root 56, and this becomes 60 root 56 divided by 56. This is equal to six. Okay, so this is equal to if we simplify, so this will be 15 by 14 multiplied by root 56. 15 by 14. Okay, so this is x. Now this will imply, now we just need the we have to find the area of the trapezium. So just now we need to find the sum of the parallel sides of the trapezium. The sum of the parallel sides is x plus 7x. So this implies that sum of, or let's say this implies that AB plus DC will be equal to x plus 7x meter. This is equal to 8x meter. This is equal to 8 multiplied by 15 by 14 root 56 meter. This is equal to 2, 4, 7, 60 by 7 root 56 meter. So the sum of the parallel sides of the trapezium is 60 by 7 root over 56 meter. Okay. Now please do not worry about the lengthy calculation. In my problem we are having roots. Maybe in your problem, the problem you will be given, you won't have any roots. All the values will be given such that you will have all numerical values, that is all integer values. So we have the sum of the parallel sides as 60 by 7 multiplied by root over 56 meter. So this implies that area of trapezium ABCD will be equal to half multiplied by AB plus DC, as these are the parallel sides. AB and DC are the parallel sides, and h, the height of the trapezium. So this is half multiplied by AB plus DC is 60 by 7 multiplied by root over 56, and what was height h? Our height is already given to be 20. So this much meter square will be the area of the trapezium. We have to simplify this. Okay. So we have 2 cancels 20 with 10. So we have kind of 600 by 7. Now root over 56 meters square. Now this is 600 by 7. Now what is root over? Now we have to match, we have to bring the answer so that it matches with the given choices. In the choices we can see some square root, that is square root of 7 by 2 or square root of 2 by 7. We have to find the area in that pattern. So what is 56? 56 is 8 multiplied by 7. Okay. Meter square. This is equal to 600 by 7 multiplied by 8 is 4 into 2 into 7 meter square. So this is equal to 600 by 7. I can bring out 4 from the square root in outside, and it will be 2. Square root of 4 is 2. So we have 2 and then multiplied by 2. Inside the square root we are having 2 multiplied by 7. Okay, so 600 multiplied by 2 is 1200 divided by 7. Okay, and then we have inside square root we have 2 multiplied by 7, which is nothing but square root multiplied by square root of 7. So this is equal to 1200 multiplied by square root multiplied by square root of 7, and the denominator 7 we can write as square root of 7 square of square root of 7. Now 1 square root of 7 will cancel. The numerator, the square root of 7 in the numerator will cancel the denominator with square root of 7. So this becomes 1200 square root of 2 divided by square root of 7, this much meter square, which is equal to 1200 multiplied by square root of 2 by 7 meter square. So this should be the area of the trapezium. Do we have such a choice? It is not there. I think I have made I have done some mistake in giving the choices. The answer is 1200. So in the choice D, as you can see, it is 2400 multiplied by square root of 2 by 7. So actually I think by mistake I've given the choice D. It should be 1200. So anyway, so the answer is 1200 multiplied by square root of 2 by 7 meter square. So I hope you understood how we applied the concept of finding the area of a trapezium based on all its sides to solve this problem. Okay, let's see the next problem. PQRS is a trapezium where PQ is parallel to SR. One parallel side is 26 meter longer than the other parallel side. One parallel side is 26 meter longer than the other parallel side. The length of non-parallel sides are 28 meter and 30 meter. Okay, so the length of the non-parallel sides are given, but the length of the parallel sides are not given absolutely. They are given, they are relatively given. That is, it is given that the larger parallel side is larger than the smaller parallel side by 26 meter. If the area of the trapezium PQRS is 1680 meter square, then find the length of the smaller parallel side. Area is given. Area is given. Okay. Area is given. We know the length of. Okay, so let's draw. It is always better when you solve any problem on geometry or mensuration. Always try to draw the figure. Always try to draw the rough figure. So let's say PQRS is the trapezium. PQRS is the trapezium. PQRS where PQ is parallel to SR. Let's say the larger parallel side is SR. Okay. Let's say the non-parallel sides PS be 28, this be 28. I'm ignoring the unit, and this is QR be 30. Okay. And what else is given? If this is X, if we consider the length of the smaller parallel side is X and the length of the larger parallel side is Y, we are given Y minus X is equal to 26 meter. Okay. Y minus X is 26 meter. Okay. Okay. The height is not given. The height of the trapezium is not given. The area is given. Okay. So let's see. Let's see. Okay, so let's first try to construct the triangle. So definitely I will draw a line parallel to PS. Draw line parallel to PS. Let this be T. PS and QT are parallel. Definitely the triangle I have constructed is QTR, and obviously the height of the triangle as well as the trapezium is, let's say, U. So this is H. Okay. So okay. So in triangle QTR, the base we know will always be equal to the difference of the parallel side of the trapezium, which is already given. The base will always will be the base which is in this case is TR will be equal to Y minus X, which is given to be 26 meter. Okay. And what will be QT? QT will be equal to PS, which is 28 meter, and also QR is equal to 30 meter. So we have found, we already know the length of the sides of the triangle we have constructed QTR. Okay. So the tricky part is that so what we need to find the length of the triangle that we are constructing. The two of its sides will be the two non-parallel sides of the trapezium, and the length of the base of the triangle we are constructing, it will always be the difference of the parallel sides of the trapezium. So that is the reason in this problem only the difference was given, saying that one parallel side is 26 meter longer than the other parallel side, which means that the difference of the parallel side is 26 meter. Okay. So now we have for triangle QTR, what is smallest, that is the semi perimeter, is half multiplied by QT plus TR plus QR. This is equal to half QT, the perimeter is QT plus TR plus QR. Okay. So half multiplied by what is QT? QT is 28. What is TR? TR is Y minus X, that is 26. And what is QR? QR is 30. So this much meter. This is equal to 28 plus 26 is 54. 54 plus 30 is 84. 84 by 2, that is 42 meter. Semi perimeter is 42 meter. Okay. Okay. Then we can find the area A of triangle QTR will be equal to, using the Hero's formula, S multiplied by S minus QT multiplied by S minus TR multiplied by S minus QR. This is equal to square root of what is S is 42, what is for S minus QT will be 42 minus 28, and S minus TR will be 42 minus TR. What is TR? 26. And S minus QR will be 42 minus QR is 30. Okay. This much meter square. I am ignoring the meter square. I hope you will understand. So this is equal to 42 multiplied by 42 minus 28. 42 minus 28 is 14, multiplied by 42 minus 26 is 16, multiplied by 42 minus 30 is 12, the square. Okay, so this is equal to 42 is 7 multiplied by 6, 14 is 7 multiplied by 2, leave 16 alone, and 12 is 6 multiplied by 2. Okay, so now you have to use a little bit of concept of finding the square root of numbers. So we see there are two 7, so 7 multiplied by 7, we have 16 multiplied by, we have 2 6, and we have 2 2's. So definitely this will be equal to 7, square root of 16 is 4, 6, 2. This much meter square, which is equal to 6 into 4, 6 into 6, 4 into 6 is 24, 24 into 2 is 48, 48 into 7 is 48 into 7 is 56, 48 into 7 is 56, 33. 336 meter square is the area of the triangle QTR. Okay, so now we know that the height of the triangle as well as the trapezium will be height is QU. QU, that is height, will be, we know, is twice the area of the triangle divided by the base. By the base, which is base is always the difference of the parallel sides. Base is TR. TR. What is A? A is 336 divided by what is TR? TR, the difference of the parallel side, which is given to be 26 meter. Okay, 26 meter, 13. So this is 336 by 13 meter. So the height of the trapezium we have found to be 336 by 13 meter. Okay, so what was the question? Then find the length of the smaller parallel sides. Area of the trapezium is given. We find the length of the smaller parallel sides. So we need to find the parallel sides basically. Okay, we know the area. This is the height. we know the height, area is given. Okay, so area of trapezium PQRS is equal to half multiplied by the sum of the parallel sides, which is x plus y. We know the area, we have found the height of the trapezium, and the area of the trapezium is already given, so we can easily find the sum of the parallel sides of the trapezium into height, which is equal to area is given to be equal to 1680 meter square. 1680. Okay. Now this implies half multiplied by x plus y multiplied by height h, we already know to be 336 by 13. This is equal to 1680. So from here we can easily find the sum of the parallel sides, that is x plus y, will be equal to 1680 multiplied by 2 multiplied by 13 divided by 336. What is this? What is this? Okay, let's divide by 4. 8 and then 4. This is 420, and then 2 divides 42. Okay, so this is 10. So this is equal to 130. X plus y is 130. We have found x plus y is 130. So we have x plus y is 130. We also know that y minus x is 26. That is the difference of the parallel sides is given to be 26 meter. So we know y minus x is 26. Now if I consider x plus y as so this is basically two equation in two variable. Maybe you are not yet familiar how to solve, but this is a very simple equation. It is very easy. So you can see that x plus y is 130. I am considering this equation as number 1, and if y minus x is equal to 26, I am considering this equation is equation 2. Now if I add up these two equations, if I add up, that is, I will add the LHS, I will add the RHS, and I will equate the sum of the LHS with the sum of the RHS. I will get x plus y plus y minus x is equal to 130 plus 26. Now the left hand side becomes x cancels out, and we have twice of y is equal to 156. So this implies y is equal to 156 divided by 2, which is equal to 78. This is meter. So this will imply what will be x. X is the length of the smaller parallel side. So x will definitely be y minus 26. This is equal to 78 minus 56. 78 minus 26 meter, which is equal to 52 meter. So the x is the length of the smaller parallel side. So the question was asking the length of the smaller parallel side. So the correct choice is D. So these are two very I think these two problems will give you a good application of the concept of finding the area of a trapezium based on the length of all its sides. In the next topic, in the next video, I will explain how we find the area of a trapezium, area of an isosceles trapezium, where the length of the parallel sides and the length of each equal non-parallel side is given. The concept will be same. It will also be based. You can find the area of a trapezium, of an isosceles trapezium, based on this concept, that is using the Hero's formula, but you can also use Pythagoras theorem. Using Pythagoras theorem, we can also find the height of the trapezium. I will discuss that in the next video. I hope this video was beneficial. If it is so, please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So once the next video is complete, where I will discuss how to find the area of an isosceles trapezium, I will solve the problems from the textbook of author R.S. Aggarwal, that is exercise 18a. I will solve the problems of exercise 18a, and then I will start the topic of finding the area of polygon. So these videos are coming soon. I will end the video here. Thanks for watching, and until the next video, take care and bye.